Okay, good. So let's evaluate oh, let's evaluate the residue at P naught is equal to omega P. Okay, now it's just some tedious computations, but let me just go through one with you so that you know exactly what needs to be done. So let's take a look at the integrand. So we're going to want to make an expansion of the integrand around P naught is equal to omega P. So the integrand looks like I over 2 pi to the 4. We then have e to the I P naught Tx minus Ty minus I P dot X minus Y. And this is sitting over P naught squared minus, and I'm going to write this as omega P squared. And remember that omega P squared is P dot P plus M squared. Notice that I haven't included the I epsilon, and in fact, I can drop the I epsilon now. The only role of the I epsilon is to tell me which residues I should keep when I close the contour in the two possible ways. Okay, and I've summarized that in the diagram. So I've defined which residues I'm going to keep. We no longer need the I epsilon. Okay, so let's now start to expand this close to P naught is equal to omega P. So let me just put that here so that you know what we're doing. Expand close to P naught equal to omega P. So I'm expanding in the variable P naught, and I'm close to the point where P naught is equal to omega P. So what is this equal to? Well, I've got 2 pi to the 4. Now I'm going to write the exponential in this way. I'm going to write e to the I. I'm going to put P naught minus omega P times by Tx minus Ty. And then I'm going to say plus I omega P Tx minus Ty. So that's just the first term in the exponential. The advantage of doing this is that P naught minus omega P is now a very small number. And we've got minus I P dot X minus Y. Good. This will be over. So we will have P naught minus omega P. Good, that's a small number. And then multiplied by P naught plus omega P. That's not a small number. So how can we rewrite this? Well, this is I over 2 pi to the 4. We'll have e to the I, P naught minus omega P, Tx minus Ty. And then we'll have the other stuff, which I'm going to separate off. E to the I omega P, Tx minus Ty, minus I, P dot X minus Y. That second term that I factored off doesn't depend on P naught at all. So I'm not going to be expanding that at all. And then we've got P naught minus omega P. Then I'm going to write the second term as P naught minus omega P. So that's small, but then I have to add in plus 2 omega P. Good. So now what is this equal to? Well, I've got I over 2 pi to the 4. I'm going to pull this exponential up front, e to the I omega P Tx minus Ty minus I P dot X minus Y. Then I have got times by, we're going to have 1 over P naught minus omega P. We're going to have the second bit of the exponential that I didn't include yet. So in fact, let me put that in a different color. I want to make that clearer. Oh, let's do this. I want this bracket back. And now let's use the blue and write in e to the I P naught minus omega P Tx minus Ty. And now for the second bracket in the denominator, I am going to write that as 1 plus P naught minus omega P over 2 omega P. So out of this red bracket, I've pulled out 2 omega P, and I am going to include a 1 over 2 omega P on the first line. So I haven't done anything except to rewrite the previous expression. And now I can write it as follows. So this is equal to, let me first of all collect all of the stuff in black. So we've got 2 pi to the 4, we've got e to the I omega P, Tx minus Ty, we've got minus Ip dot x minus y. This is over 2 omega P. And then this is multiplied by, so we've got 1 over P naught minus omega P. Good. Then we've got the exponential. Now, the exponential, you know the expansion of the exponential. This will be a sum from n is equal to 0 to infinity. So e to the x expanded to infinity is a sum from n is equal to 0 to infinity of x to the n over n factorial. Here, x is I P naught minus omega P times by Tx minus Ty raised to the power of n over n factorial. And then we've got the red term. And this is 1 over, this is of the form 1 over 1 plus x, and 1 over 1 plus x is equal to a sum from n is equal to 0 to infinity minus x to the n. Okay, this is maybe one of the first geometric series that you ever learned. So this will be a sum. Let's make it m is equal to 0 to infinity of minus E naught minus omega P over 2 omega P to the m. Okay. And okay, good. We will continue in a moment.